In earlier session, we talked about priority scheduling, which was a non-preemptive mode or non-preemptive method. Now we'll talk about the preemptive method. Same understanding like with respect to the priority. Only thing is like when a process starts execution, okay, now it reaches to some time unit on a timeline of process execution, and it sees that an high priority job comes into picture or high priority process comes for execution. Then a process would be preempted and the high priority process would be given chance to execute. So we will consider the same example that we talked in the previous video. Let us say we have processes P0, P1, P2, P3, P4 with arrival time to be 0, 1, 2, 3, 4. Priority again 2, 1, 3, 2, 1. Burst time to be 5, 3, 8, 6, 4. Now let us say P0 starts at 0. Now when it reaches to 1 timeline, it sees that process P1 arrived. So as it is having priority as 1 and P0 was having priority to be 2, so P1 is having highest priority. So P0 would be terminated or preempted for a while, and then P1 is given chance to execute. And this is how this preemptive works. So P0 preempted, P1 executes. Then it sees that because bus time is 3, P1 completes at 4. So now as we are at timeline 4, so all processes have arrived. Now process P0 was having priority 2, process P2 is having priority 3, process P3 is having priority 2, and P4 is having 1. So P4 would be given chance to execute. So P4 finishes at 8. Now all processes which are having priorities remaining are P0 and P3 with priority 2 and P2 to be having priority 3. So now in both these cases, highest priority is 2. So that's why P0 is given chance to execute for the remaining time bus time which it had. Earlier it had 5. Now as it completed already 1 time unit, so remaining 5, so it will finish at 1. Now P3 with the priority to be 2, it will complete at 6 time units, so finishes at 18. And similarly, P2 at the later stage with priority to be 3 with time bus time to be 8 time units, finishes at 26. So like completion time would be computed as for P0, P0 finishes at 12, P1 finishes at 4, uh, P2 finishes at 26, P3 finishes at 18, and P4 finishes at 8. So subsequently, now we will compute turnaround time. So turnaround time would be like completion time minus arrival time. So 12, then 3, then 24, then 15, then 4. Now you must have seen here, like earlier with the priority scheduling with a non-preemptive method, we had some change in the turnaround time. Right now, this is somewhat modified one. Correct. So because P0 was preempted, so that's why the some small change is seen there. Correct. So subsequently, the turnaround time computed would be 12, 3, 24, 15, and 4 with completion time minus arrival time. So average turnaround time comes to 58 divided by 5, 11.6. Now waiting time. So we know P0 started at 0. Okay. But it was preempted because this is a preemptive algorithm. So P0 was given chance at 8. Correct. Again. So as it already completed a 1 time unit, so the total waiting time for it would be considered as 7. P1 arrived at 1, given chance to execute at 1, that's why 0. P2 arrived at 3, but given chance at 18, correct? Sorry, P2 arrived at 2, given chance at 18, that's why waiting time is 16. P3 arrived at 3, okay, and like it was given chance to execute. So the ultimately like 12 minus 3, 9. And P4 arrived at 4 and given chance at 4. That's why waiting time would be 0. So total the waiting time for each process would be now 7, 0, 16, 9, and 0, which results to 32 divided by 5. So average waiting time would be computed as sum of that 32 waiting time, okay, divided by 5, so which results to 6.4. So this is how primitive scheduling algorithm works.